Today we're starting the last unit of the year, and the first lesson is on degrees, radians, and arc length. So just talking about basic angles in the coordinate plane and converting between degrees and radians. So to begin with, we're going to learn how to convert something that's in degrees to radians, which is definitely a new topic for you guys, and then vice versa, so converting radians to degrees. If you're converting from degrees to radians, you need to multiply the number of degrees by pi over 180. And if you're converting from radians to degrees, you need to multiply the number by the opposite, so that would be 180 over pi. And to just see what this looks like when you're actually converting, let's take a look at the examples. For the first example set, we're converting each degree measure to radians, and we're expressing our answer in terms of pi, meaning you should not be using your calculator to write out a final answer. You should be leaving your answer as a fraction with pi. One thing that you should do is you should simplify the fraction. So looking at number one, we have negative 60, and above we are converting from degrees to radians. So in this case, we are multiplying by pi over 180. That means we take negative 60 and we multiply this by pi over 180. This just becomes a fraction being multiplied by another fraction. Recall that 60 is technically over 1. So you can eliminate common factors between the numerator and the denominator. I know right away that 60 and 180 have a common factor, and that would be 60. So 60 goes into itself once, you're left with a negative 1, and 60 goes into 183 times. So then you just multiply across. You multiply your numerators, and then you multiply your denominators. When I multiply the numerator together, I have negative 1 times pi, or just negative pi, divided by 1 times 3, or 3. This is my answer in radians. So that means negative 60 degrees is equivalent to negative pi over 3 radians. All right, looking at number 2, we have 120 degrees. We're going to multiply this by pi over 180. We're going to simplify numerator to denominator. I recognize that 60 goes into both 120 and 180. So I can divide out a common factor of 60, leaving me with 2 in the numerator and 3 in the denominator. Multiply your numerators together, multiply your denominators together. You have 2 pi over 3. And this is your answer. All right, on the flip side, if we're converting from radians to degrees, you multiply by 180 over pi. And a trick to know which one you're multiplying by is if you have the symbol pi and you're trying to convert to degrees, you need to eliminate pi. The only way to do that is to make sure that pi is in the denominator. So 180 over pi, that has the value of pi in the denominator, which will allow you to cancel those two values. And that's what you want to do. So Again, multiply by 180 over pi. Right away, we can eliminate the value of pi, and then I can either multiply everything together and divide it out, or I can simplify like terms. It doesn't really matter what you do. I think that I'll multiply everything together. So I'll multiply the numerators. What's left is negative 3 times 180, which leaves you with, or I'll just write that, negative 3 times 180, divided by the denominator, which is 8 times pi. Left over is just 8. So in this case, again, you can either simplify that, or you could just type this into your calculator. And that's what I'll do. When I type that into my calculator, I end up with negative 67.5, and we just converted that to degrees. So don't forget your degree symbol. Number 2, we have 5 pi over 2. I know it's in radians because I see the pi symbol. So in order to eliminate that, I'm going to multiply it by 180 over pi. Right away, I can cancel those values of pi. And this one, why don't we simplify it before we multiply together, just so you can see the difference between simplifying first versus just typing into your calculator. So here I can eliminate the 2 in the denominator, and 180 will become 90. So now we eliminated both our denominators, leaving a value of 1. All we have left is our numerator, which is 5 times 90, and our solution would be 450 degrees. Now I could have typed 5 times 90 and then in my calculator done divided by 2, and that you would have ended up with the same answer. So here's just a quick note of what we accomplished in this section. You have degrees to radians. If you're going from degrees to radians, you are multiplying by pi over 180. However, if you're going from radians to degrees, you're multiplying by 180 over pi. Next, we have arc length. For a circle with a radius labeled r and a central angle labeled theta, which is going to be in radians, the arc length, which is labeled s, equals the product of r and theta. So let me just highlight a couple of the values that you need to look at. So theta is located here. We have our radius. And we have the arc length S, which is located located here. This description probably sounds confusing, so if I was to take that description and write it out into a formula, the arc length represented with a variable S is equal to the product of the radius times theta, so r times theta. As long as you can find these 3 values, you can fill in this equation. So looking at the first example and following along with what we just talked about, we need to make sure that our angle is in radians. So radians always includes pi, which here it does, so we're good, that's in radians. And then we need to fill into the formula of arc length represented as S, so that would be this length here, is equal to the radius times theta. Filling in my formula, the radius is 5 times theta, which is 3 pi over 7. Okay, that's this number here. I highlighted it in green. I'll highlight it in green here. I'll also highlight my radius in blue. There's my radius. So when I multiply these two values together, my final answer for arc length, so for the value of S, left in terms of pi is 15 pi over 7. And we're dealing with centimeters here, so make sure centimeters is in your final answer. For number 2, following the formula of arc length S is equal to the radius times theta, we need to start by checking to see if our angle measure is given in radians, which in this case it is not. So that's where I'm going to start. Kind of make a side note to yourself and convert 270 degrees to radians, which would require us to multiply by pi over 180. When I multiply by pi over 180, 90 goes into both 270 and 180. It goes into 270 3 times and 180 twice, leaving me with 3 pi over 2. So I'm going to replace 270 with 3 pi over 2. It's equivalent. One of them is in radians, one of them is in degrees. So now that I have this value of 3 pi over 2, I can substitute that value into my arc length formula. My arc length S is equal to the radius of 30 times my radian measure of 3 pi over 2. When I multiply these values together, I end up with 30 times 3, which is 90 times pi divided by 2. And for my final answer, I can just simplify this fraction. My arc length is going to be 45 pi, and we're dealing with inches, so 45 pi inches. And in case you missed what I was talking about with what arc length is, I may not have been completely clear with that, but now that we've gone over some examples, the arc length is finding just this length here. Okay, you guys are all familiar with finding the circumference, which is the length all the way around the circle. But now we're dealing with finding just a partial length of the circle. So whatever is highlighted in bold on my examples is going to be the length you're looking for. All right, please follow along as I complete the on your own section. And the last part of the notes is something I would like everyone to complete by themselves. And this is called the unit circle. It's something we use a lot towards the end of the year in pre-calc. So what I'm expecting everyone to do for this part of the note sheet is to look at every angle measure. So we have 30 degrees and convert it to its corresponding radian measure. So working around the unit circle, next we would be looking at 45. So if we were to convert that to radians, what would our solution be? Then we have 60. I want to know what the radian measure is. So fill in every open box on this unit circle by converting the degrees to radians.